standard normal distribution with the mean of 0 and the standard deviations of 1 using the table only. Find the value in the standard normal distribution. Find P of the z-score less than 1.96. The first thing we need to do is to draw a graph. Label the z-score 1.96. The standard normal distribution has a mean of mu 0 and the standard deviation of sigma equals 1. If z is 1.96, then it is on the right hand side of the mean 0. So we just simply draw a straight line and label 1.96 somewhere on the right hand side of 0. The notation less than indicates that this is the area or probability on the left hand side. To use the table to find this area, we first locate 1.96, which is from the positive part of the table, 1.9 in the first column, and then we go to the right along the 1.9 row and stop at 0.06. The corresponding probability or area is 0.9750. And so the answer is 0.9750. We're looking for the probability where z is greater than 1.34. Same thing. First, we draw the bell-shaped curve, label the mean 0 in the middle, and we would indicate 1.34 at the z-score. That z-score is positive, and so we would draw a vertical line on the right-hand side of the mean, label 1.34. The symbol greater than indicates that we would need to shade the right-hand side. The table only gives us the area on the left-hand side, but that is okay. We just need to find the area on the left-hand side and then take 1 minus to get the area on the right-hand side. The area on the left-hand side of 1.34 z-score is found in the table. First, locate 1.3 from the first column and go to the right and stop at 0.04. The corresponding probability is 0.9099. And so this area is 0.9099. The area on the right hand side is 1 minus 0.9099, which is 0.0901. Alternatively, using symmetry, we see that if we were to reflect it to the left hand side, then this shaded area is on the left hand side of negative 1.34. And so using the alternative method, we could look up for the z-score, negative 1.34, and read off the answer directly. Negative 1.3 from the first column and go to the 0.04 in the first row. There it is. Negative 1.34 has the corresponding area of 0.0901. Next, find the probability between the two z-scores. One is negative 1.53, which is on the left-hand side of the mean, and another one is negative 1, which is also from the left-hand side of the mean. And so we're looking for this area between the two z-scores. First, we need to find the area on the left-hand side of the larger z-score. With the z-score of negative 1, the corresponding probability from the table is, we would locate negative 1, but negative 1 in two decimal places is negative 1.00. And so we would go to the first column and locate negative 1.0, negative 1.0, and then go to the right but stop at 0.00. This has the corresponding probability of 0.1587. So this is 0.1587. With the z-score of negative 1.53, we go to negative 1.5 and go to the right and stop at 0.03. the corresponding area is 0.0630, P equals 0.0630. And then we will subtract the two. 0.1587 minus 0.0630 will give us 0.0957. Next, find the z value separates the bottom 20% of the area from the remaining area. We would draw the graph still, but this time though, we know that half of this area is a 0.05, and so the bottom 20% is on the left hand side somewhere. This area is 20% or 0.2000. It is customary to round the probability to 4 decimal places, and we're asked to find the corresponding z-score. Now this time, we do not look up for the z-score at first. We find the 4-digit number 0.2000, 0.2 for 20%. This is 0.2090, 0.2061, 0.2005, 0.1977. So there is no exactly 0.2000, but we know that 1977 is less than 0.2000 and 0.2005 is more than 0.2. And so we need a compromise here. There is no precise 4-digit 0.2000 that we're looking for, but we found two numbers where 0.2 is between. The first number, 0.2005, has a corresponding z-score of negative 0.8, and then we go up 4. The second probability, 0.1977, has a z-score of negative 0.85. And since the area that we're looking for is in between what two z-score here, one is negative 0.84 and the other one is negative 0.85, and so we will settle for the number in between, which is the average of the two numbers. If we take negative 0.84 and add negative 0.85 and divide by 2, we will get negative 0.845. So the z-score that will separate the bottom 20% from the top 80% is negative 0.847. Next, find the z-value that separates the top 5% from the remaining area. And so first we draw the curve. This time though, we're looking for the top 5%, which is 0.0500, and we're looking for this z-score. Remember that the table only gives us the area on the left-hand side. If the right-hand side is 5%, then the left-hand side have to be 95% or 0.9500. Similar to the previous part, we first need to find the 4 digits number 0.9500 from the table. 0.9505 is there, 0.94, and so a little bit more than 95 and a little bit less than 95. This time, similar to the previous one, we would use the z-score in the middle. With the area of 0.9495, the corresponding z-score is 1.64. With an area of 0.9505, the corresponding z-score is 1.65. And so we will settle for the middle number, which is 1.645. If we found the exact 4-digit number, then we would simply use the corresponding z-score. But if the 4-digit number that we're looking for is between any two numbers from the table, then it is usually the case that we average the two z-score. We do not average the area.